BGG, GoogleNet, or Inception. Today we're going to start talking about ResNet and some of the variations on that. And what you should see here, what we're trying to show here in this picture is that, remember, there's this box that's saying how many layers there were in each of these networks, and first one has 8 layers, probably deeper than most neural networks at the time. We get to, in a couple of years, 22 layers, but then all of a sudden these submissions start having a whole bunch of layers. We go from 22 to ensembles of models that have 152 layers. That's a huge jump, and a real technical challenge that we'll talk about today, like what that challenge is, and then how the architecture known as ResNet kind of deals with that.
How shallow is shallow? Is it like 3 layers?
What's that?
How shallow is shallow in like the first 2?
Yeah, these aren't even these are statistical models. These aren't even neural networks. So, really importantly, in 2015, with these really deep models, we go from a top 5 error rate of 6.7 to 3.6, which is now lower than typical human performance on the ImageNet data set. So we actually now get quote unquote superhuman performance by a neural network, which is fascinating. Actually, it's really quite amazing. Yeah.
How much training did the human get?
Yeah, that's a good question. That paper's from 2014. It came out then. I don't really know the answer to that. Certainly not nearly as much as the networks did. Right?
Like, if we give them more epochs, will the human overfit or anything?
It could be. It could be. It's a good question. The unfortunate thing is that humans are too lazy, and we'll never know the answer. But machines will just do this. So, yeah. But I like that perspective. It's like a good way to think about this. Well, what advantages do the machines really have over humans? When we get to talking about like reinforcement learning and like how networks learn to play, games, you'll see that they in their training they end up playing like, tens of millions of games, right? So even if you're like a diehard player of chess or Go like that, you're never going to approach that many games, right? So, anyways, it's a cool perspective. Okay, so yes, another perspective on this revolution of tech. So remember, we had these pictures of like the neural networks, right? So we have our 8-layer AlexNet, our 19-layer BGG, and then we have our 152-layer ResNet. So just to put it in perspective, like it's a whole bunch more layers, and yeah, there's another perspective on that. I was winning ImageNet until a deeper model came along. Wow. Okay, so what is this? It looks, you see something about, we're going to talk about these pieces here, but you see something about the architecture here. Simple architecture. There's again a bunch of 3x3 convolutional layers that kind of all stack together. And what you're seeing in this kind of call out right here is just any one of these blocks right here. You have 2 convolutional layers with the ReLU in between. Then you have this kind of interesting connection that goes around these 2 layers from here and is added back in there at the top. So this is what's known as a residual block, and we're going to be talking about this. But basically, like this network was so powerful and amazing at the time that not only one with superhuman, that you should be able to get at least as good as a network with one less layer, because you can just have like all the layers up to that layer you added can just be can be the old network, and then the next layer that you add